Hello, everyone, and thank you for attending today's webinar, Lithium Ion Batteries, the Safe Solar Storage Solution. I'm Kelsey Misbrenner, editor with Solar Power World. Before we begin, we wanted to let you know about our application widgets at the bottom of your screen. You can move and resize them however you like. Slides are available to view at any time via the resource widget. Submit any questions related to today's webinar via the Q&A widget. Our presenters will send answers afterward to the email you used to sign up for today's webinar. We encourage you to tweet with us. Simply sign in through the Twitter box and then use today's hashtag. It'll automatically be added to your tweets. And finally, if you're watching this on demand, you can still use all the features I went over. Let's get started with today's webinar, Lithium-ion batteries, the safe solar storage solution. Today's speakers are Owen Fox, Brian Pasquill, and Jordan Little. Owen is the storage product manager for CivicSolar. He manages relationships with the company's manufacturer partners, vets technologies, and proposes the highest quality and most cost-effective solutions to include in their product portfolio. Brian is the Solar Specialty Channel Manager at Schneider Electric. He has been in the solar industry for 10 years and began by owning an installation business for 8 years. Brian has expertise in PV, solar thermal, wind, and microhydro. Jordan Little is one of Simpliphi Power's applications engineers, in which she provides technical support for Simpliphi's customers with all of their sizing, design, or installation needs. Prior to Simpliphi, Jordan led the commercial division for Hawaii's #1 EPC. And now I'll turn it over to Owen.
Thank you for the introduction, Kelsey. This is Owen Fox here with CivicSolar. And thank you all for tuning in to this webinar today. Energy storage is a really exciting space filled with crazy growth projections, all kinds of hype, and ultimately lots of confusion. So today I will be talking about CivicSolar, what we see as the energy storage market, and ultimately I'll provide you with some broad brush guidance on how to approach the energy storage projects that you are all seeing today. CivicSolar is a national solar power equipment distributor founded in 2010. Our founding was predicated on a lack of responsiveness, efficiency, and basic understanding of the solar market from existing distributors. Specifically speaking about energy storage, what sets CivicSolar apart from the rest? CivicSolar is an in-house engineering department for design. We're constantly honing in on the optimal products for your projects. We have just-in-time delivery for your projects so you stay on schedule, and we are constantly watching technology develop for tomorrow's energy storage projects. We have supported customers all the way from off-grid cabins, stretches of highways with solar-powered billboards, residential backup, C&I demand charge management, and everything up to multi-megawatt-hour microgrids for diesel gen offset. So let's take a look a little bit at the energy storage landscape that exists today. When talking about the energy storage value chain overall, it's complicated. When specifically talking about grid-tied storage, there are 3 stakeholder groups. There's the ISOs, the utilities, and the customers. There are 3 portions of the grid: transmission, distribution, and behind-the-meter services. So when you add all of that up, there are about 13 subcategories, and any given storage project can be a blend of all of the above. So how do you navigate a sale when 95% of all storage inbounds come as a customer's demand for energy storage backup? A lot of the news outlets, publications, a lot of the analysis done online that end users find simply terms energy storage with backup. So how do we unpack that to effectively sell energy storage to any end user? First and foremost, we have to accept that energy storage is not for everybody. Energy storage is a very nascent market. It's often regionally driven, customer specific, and the equipment design is unique to every single installation. Not sure why everything is priority number 1 here, but I like it because they're all equally important. First and foremost, we have to understand the market. What is the rate structure? What are the local incentives? Those are going to dictate the payback period and the ultimate structure of the storage system. What does the customer want? How much are they willing to pay for storage? And what is the utility they're working with? Ultimately, once we have those 2 down, we can define the project objective, choose the application, and then actually design products in that project. At the end of this, I'll talk a little bit about financing, what we've seen with financing, and how CivicSolar has some options for installers if you are all interested. As you can see in this map here from GTM Research, the energy storage market is extremely fragmented. This map was published in 2016, so it's a little outdated and there aren't pilot projects specifically designed into this, but there are a slew of different rate structures across the United States. Time of use, demand charges, storage-specific retail rates. There are a slew of different pricing structures based on those rates. Understanding how your customer fits within that rate structure is going to be crucial to designing the economics behind any energy storage project. Also, many states and regions and local utilities offer rebate programs or local incentives. In California, the most publicized rebate structure is the SCHIP program. We actually ran a webinar on that you can find on YouTube at CivicSolar's YouTube website that goes over the whole structure of that program and how you can sell into the SCHIP and how we can help you out with that. But there are also many local pilot programs. I live in Austin, Texas, and I dug in and found that there's actually an energy storage pilot program in Austin, Texas. I assume that there are plenty of these pilot programs across the United States, depending on the utility that the customer is in, but ultimately understanding what those rate structures are and the incentive structures are going to give you a baseline of what is feasible. So you understand the rates, you understand the local incentives, but what sort of budget does the customer have to spend on storage? Oftentimes we see that expectations are larger than reality because storage costs are not PV solar costs. The storage market is smaller than the PV solar market. There's less capacity installed into the United States than solar, and ultimately the production capacities of storage manufacturers are not yet at the production capacities of solar manufacturers, solar-specific manufacturers, I should say. So we need to know the budget, and ultimately if the customer wants a financing package, it's important to know what their cash flows are if they're a commercial customer or their FICO score if they're a residential customer. But more important than that, what does the utility data say about this customer's load? We need 12-month data, and ideally with 15-minute intervals, because it's really important to understand where the customer is using power and when the customer is using power. The peak daily loads often dictate the economics for C&I customers, and for off-grid and even residential, it dictates the amount of capacity you need to shoot into their subpanel. Without that, all we're working with is a monthly average, which doesn't optimize a solar plus storage system. So it's really important to get the utility data or come up with some expected use data to come up with a load profile. So now you understand the market, you understand the customer. So at this point, you can easily optimize the application. 95% of inbounds are emergency backup. Maybe at this point, now that you have pitched to them the economics of a different system, they are not that interested in emergency backup. But if they still are, you can always add capacity for emergency backup and design the system accordingly. However, there's the time of use arbitrage, there's the demand charge management, and there's the self-consumption. Now with the application, we still have to install products. So how do you choose the technology? How do you handle the overchoice of products in the market? There's two really key components to doing that. And it doesn't point out products that are specific for your project, but partner with a supplier that has a plan for storage now and in the future, and partner with manufacturers that have a history in storage. And I mean a history in storage by a basic corporate history does not mean a history in storage. You want to partner with companies that have been in the storage market from the beginning, have gone through all of the trial and error with designing and honing their product to perfection, and will be committed to the storage market for the long term. We believe that Simpliphi and Schneider are examples of a solution that can supply an energy storage system with both a history in storage and an expertise in storage. So with all those components, you have the baseline of how to sell an energy storage project. I'll touch a little bit on financing before I hand off the mic to Jordan to talk about Simpliphi and her battery solution. What we've seen is that there is major issues with designing PPAs into storage, which is not unexpected. It's really hard to monetize customer savings in a 20-year contract. It's also really hard to monetize the risk of rate restructuring. If a utility were to restructure their rates tomorrow and decrease their tiers by 5%, ultimately that's going to change your payback. And ultimately that would change your power price if you had known about that structure in the future. There's no standard rate escalator for energy storage projects when we're talking about demand charge management, time of use, and that causes a real problem when we're talking about third-party owned systems and PPA contracts. The other issue that we've seen with energy storage finance is that financiers have a very limited understanding of storage equipment. You can talk about solar equipment and production over time and the weather and the overall warranty, but when you start talking about optimizing energy storage and you tell your financier that you are going to charge a 20% premium for your energy storage package because it optimizes the depth of discharge, they often lean back in their chair. So we've seen an issue with that, and I don't think that's going to change in the near future. I think it will change once utilities get an understanding of how to value energy storage themselves. But until then, CivicSolar does have some options for financing. We have some partnerships with both equipment loans, PACE programs, and operating leases that we've used in energy storage projects and have worked really well for the end user. So without further ado, I will hand over the mic to Jordan.
Hi, everyone. My name is Jordan Little, and I'm with Simpliphi Power. Just to get started, I'm going to tell you a little bit about our company. We at Simpliphi have been dedicated to offering the safest, the most efficient, and the simplest way to use energy storage. And by simple, we mean for both the installers and the end users. Our Simpliphi products optimize any power generation source, whether it's on or off grid. So if you're adding to an existing system or it's a brand new solar system that's going to be on the grid or even off the grid, we can help you out. You may or may not have heard of us before, but we've actually been in business since 2002. We have over 10 megawatt hours of energy storage deployed across the globe, but we're all made out of California. To get started, let's talk about some batteries. This is the building block of Simpliphi's technology, the Phi 3.4. And this lithium ion battery is actually part of the lithium ferrous phosphate, or LFP family. This is the same thing as lithium iron phosphate, if you've heard about that before. Before diving into why we chose LFP for our batteries, let's talk about other lithium ion chemistries. This list has some of the most popular commercially available lithium ion batteries that are used for energy storage, even in cars, in your laptop computers, in your cell phones. These are the most popular kinds of chemistry you will find in batteries on the market today. This is not a comprehensive list, but this is the most popular. If you notice, these top three chemistries all contain the same element, and that's cobalt. So to take a look, let's compare batteries that have cobalt versus those that don't. On the left, you see here the three batteries that contain cobalt. And on the right, we see LFP that does not contain cobalt. Now let's take a look at some of the disadvantages of using a battery with cobalt. Thermal runaway is a technical term for rapid, uncontrolled increase in temperature. In lithium-ion cells that contain cobalt, thermal runaway can be triggered by internal short circuits, physical damage, or overheating of the cell. The result of thermal runaway is typically a fire or an explosion. Cells that contain cobalt oftentimes experience rapid depletion after about 500 cycles. If you're doing daily cycling, that's a little bit less than 2 years. So when you get to, say, year 5, you're not going to have the same amount of energy available in that cell as you did in year 1. Cells with cobalt have to be maintained within a narrow temperature window. This is to keep them cool and to prevent any risk of thermal runaway. This often includes having to have a liquid cooling system with coolant or some HVAC. This requires extra costs and labor and maintenance. Battery cells that contain cobalt are more toxic than LFP cells. Lastly, cells with cobalt are less efficient than an LFP cell. Given this list of 5 things, Simpliphi Power has decided to choose LFP as the chemistry of choice. Some of the most popular energy storage products out there all use batteries that contain cobalt. These batteries are at risk for thermal runaway. They have a decreased life cycle. They have to maintain a narrow temperature window. They're more toxic and they're less efficient than LFP batteries. But at Simpliphi, we're using the battery without cobalt. We're using lithium iron phosphate. Because we have lithium iron phosphate, we have no issues with thermal runaway. We're going to get an increased life cycle of up to 10,000 cycles over 10 years with our batteries. Simpliphi batteries also can charge and operate in a wider temperature window. This oftentimes does not require any external heat or any external cooling to have our batteries operate safely. Because we're using LFP, we're a non-toxic chemistry. And lastly, we are 98% efficient. That means for every 100 kilowatt hours you put into our battery, you're going to get 98 out. So given these advantages, Simpliphi, we've decided to go with the LFP chemistry in all of our products, including the Access. We created the Access with our 5 3.4 batteries located in the bottom of the unit as an answer to the question from our installers of how can we implement a plug-and-play solution in the field that's easy for us and also easy for our customers. When you think of adding a battery to a solar system, oftentimes a homeowner or someone not in the industry would think you just add a battery. You put it in between your panels and you put it in between your loads. Unfortunately, it's not that simple. There has to be a lot of other components that are involved in this system design and installation. With a typical ESS, you're actually going to have multiple components to make the battery work. You're going to have your charge controller, your inverter, your charger, your communications layer, temperature sensing, your display, all these different components to actually plug into the customer's home. Since a typical energy storage system is made up of multiple components, it's going to lead to a longer design time to make sure that you're picking the right equipment for the customer's load. Most of the equipment out there available is indoor rated only. So you have to find a spot in a garage or in a readily accessible area at the customer's home to install all this equipment. When you actually do it to the installation, it typically takes multiple days to actually have everything communicate with each other and program all the settings for it to function. This also results in multiple items per BOM. So if you forget something on your truck, you have to do another truck roll to get the proper equipment out there. And lastly, the installers have to be specially trained to actually program the equipment to make sure it functions for the end user as they want it to. So our installers brought all these complaints to us, and we thought, well, what if we can take all these components and put it into a simple plug-and-play box? And that's what we came up with the Access. It contains all the inverters, charge controllers, monitoring, and the batteries that contain that LFP chemistry to make it easy for you, the installer, and simple for the homeowner. So the Access, like we said, is a plug-and-play unit. It's all made up of Schneider components on the inside and is capable of DC or AC coupling. So you can basically add it to a new PV system or retrofit it for an existing PV system. The cabinet is rated for NEMA 3R, so you can install this outdoors anywhere within a readily accessible area. There is no maintenance on the batteries, and the inverter is virtually maintenance-free. And most of all, it's top of the line in safety based on that LFP chemistry and Schneider equipment. Here's a block diagram showing most of the Schneider components involved in the Access. This way you can either interface with the grid or a backup generator depending if you're on the grid or off grid. You can DC couple directly with a PV array, or you can AC couple, say if you have microinverters or an existing PV installation. And all this is based off of the 3.4 battery. So going back to our company's mission statement, we've created the Access so that it can be safe, efficient, and simple for both the installer and the end user. And we've accomplished this by partnering with Schneider. So up next, here's Schneider.
Hi everyone. My name is actually Brian Pasquale, and I work for Schneider Electric. I am the solar channel manager for the Western United States and Canada, and I'm happy to be here today to talk to you about the products that Schneider provides to Simpliphi to integrate the power electronics with their battery in the Access all-in-one energy center. I'll start by talking a little bit about who Schneider is, where we come from, and what we bring to the table. So Schneider Electric's been around for a long time. It was started 178 years ago in France, and through growth and acquisition has become the company that it is today. With revenues in 2015 in excess of $29.9 billion, Schneider has bricks and mortar in over 120 countries and in excess of 160,000 employees worldwide. With that reach, Schneider is able to support projects around the world with a variety of products, including all of the companies that you may or may not know, such as APC, Square D, Federal Pioneer, and Xantrex, which is where the line of inverters has come from that we're going to talk about today. And so the Conext line is one of a variety of sizes of inverters that Schneider supplies, all the way from the utility grade Smart Gen that is just being released now as a 1 megawatt block, all the way down to the Conext XW and XW. Today we're going to talk about the XW and all of the associated components that have been worked in to supply Simpliphi with their all-in-one solution power electronics. The Conext XW Plus is Schneider Electric's flagship battery-based inverter. This grid-forming bidirectional inverter is scalable, reliable, and a robust solution for luxury homes and businesses. Been used for off-grid solar with remote communities, schools, gas stations, telecom towers, all around the world. Been used in battery backup power situations for gas stations, stadiums, hospitals, and refrigeration facilities. It's used for self-consumption, to do peak load shaving and demand management, and other household applications as well. It can be configured into either multi-unit single-phase or three-phase multi-clusters up to 100 kilowatt maximum. It supports multiple battery strings and has a function called energy balancing, which can reduce or even eliminate the requirement to equalize your batteries. The XW Plus has enhanced grid support and provides grid cell capability. This product is renowned for its durability and reliability. For instance, last year, this product had 20 RMAs in total for products returned to Schneider due to what was considered warranty purposes, which would have thousands of inverters sold over that period of time, and a total of 20 were returned. And of those, 10 to 20% of them were actually a warranty item, whereas the rest were self-inflicted damage by either the installer or the homeowner. This product is the cornerstone of the Simpliphi battery-based inverter all in one unit, and Schneider Electric is very proud to supply into this solution. The Schneider Conext line is integrated on the Xanbus network. And what that means is that all of the components are programmed with the same communication language. And as a result, they can work with each other to optimize how your renewable energy system operates. I'll get into that a little more after. So with the XW Plus, there is two options of solar controllers. The MPPT60, which is a 150 volt solution and would be used for smaller systems or to maintain the lower voltage, or the MPPT80, which is a 600 volt solution and can be used to minimize the number of strings that you have. As well, it can reduce the size of cabling that's required, wiring that's required to install the system, because the higher voltage allows for less losses across the distance of transmission. So they're both a very high efficiency unit, and these two controllers integrate with the Conext system. That's for the solar side. And then as well, the XW provides a dual AC input option, which allows for it to be both grid connected and connected to a generator, both with an internal transfer switch, not so that it doesn't require an external one. The auto gen start allows the system to maintain the batteries without any manual turning on or turning off. It allows for many different required inputs and conditions to start the generator. And when used with the battery monitor, it can provide actual state of charge maintenance of the batteries, so that you can program the criteria that the generator will start on. The battery monitor as well is not a standard voltmeter. It is actually a battery monitor that allows to read state of charge across a shunt, and this functionality allows for, through that Xanbus network, the inverter and the solar controllers to control how best to charge the batteries, how best to maintain them, time of day charges, so that, you know, if your power is cheap at one time and you have lots of sun, then you just focus on charging your batteries, or you sell. Whereas if you know you're going to have a period of extended darkness, you can program it so that it maintains the batteries in the state that you need them to, all communicating through that Xanbus network. As well, the system can sense whether one of the batteries is perhaps sagging, the voltage is sagging, and you can then run an equalization charge, or alternatively you can swap the batteries locations to get them into a better charging situation. These systems together operate and communicate through the XW, which then now translates into our communications piece, which is actually the real heart of the system, called the Conext ComBox, and I'll talk about that now. So now that you have an understanding of the Xanbus network and how it can help to make your system more flexible and make it more powerful, the piece as a whole, the Xanbus network can be viewed as the central nervous system of your renewable energy system. And as I said earlier, the XW Plus inverter can really be seen as the heart. And then the Conext ComBox is effectively the brain. And what it does is it provides a comprehensive monitoring and diagnostic control solution through a device that you implement into the system and then communicates with and monitors all the other systems on that Xanbus network. So what it does as the user is they'll see a system dashboard as on the screen, and what that dashboard says is all of the inputs and outputs of energy into your renewable energy system. So you can see if there's some solar coming in, you can see what loads are being fed, you can look at how much your battery is giving and taking, and how much the generator is putting out versus how much is coming from the grid. As you drill down in, you can actually get data from historical logs through every device, whether it is your batteries and you're looking at whether or not you have sufficient capacity in the batteries, or whether you might have, as I said before, through the battery monitor feeding this data, you can look and see if one of your cells might be sagging, or the voltage is getting low and the batteries need to be equalized on certain schedules, and you can get reminders of those things or push emails of faults. You can change the settings directly through the ComBox. You can actually set up the inverter system through the ComBox. You can push firmware upgrades through it, both locally and through the cloud, through a secure IP. And you can take data over the life, or as long as you want, of the system, and compare and look at whether you have enough solar, or if there's issues in the system, you can track them, and that provides the user with far more information, and very rich information and accessible information. As an installer, what it provides is the ability to monitor your customers and make sure that they aren't having any problems, or if they have a fault, you can call them and let them know that, oh, by the way, this has happened, it's given me this fault code, that implies that I need one of these when I come out. I'm going to come out and fix it at your convenience, and then it provides the option of only rolling your truck once. You don't have to take an extra set of batteries, go back for an extra set of batteries. You can take them in the first place. This system is extremely unique out there in the market today. It is extraordinarily powerful. It really ties the whole system together and gives you the control that you need to operate your renewable energy system from anywhere in the world. And that is the Schneider Electric Conext XW Plus inverter and associated components that are integrated into the Simpliphi Access all-in-one energy center. I hope this information was helpful, and if you need more, you can find everything that you need on our website, or you can get my information directly from CivicSolar, who I'd like to thank for this opportunity to talk with you today, and I hope you have a great rest of your day. Thank you.
I'd like to thank Owen, Brian, and Jordan again for being here, and CivicSolar for sponsoring today's webinar. This webinar will be available at solarpowerworldonline.com. Thank you to everyone in our audience for participating. I hope you enjoyed our presentation, and we invite you to join us for more Solar Power World webinars. Thanks, everyone.